Hi there, once again. On this video you're going to learn about the trapezium rule. It's part of the things that you need to learn in chapter 11 under the heading of integration. Alright, so you're going to learn about the trapezium rule. The trapezium rule is basically another way of working out the area below a graph and the x-axis. Okay, so let's say you had a graph like this, and you want to work out the area between x equals 0 and let's say this was 5. You could use the trapezium rule. Okay, it's different from using definite integrals from the last video. Okay, this is more of an approximation. Okay, so you wouldn't get a precise answer. It's going to be a very close approximation. Okay, so what you basically do is create strips between the area, between the points you want the area. Okay, you create these strips, and basically these strips, each of these strips is a trapezium. Okay, so each of these strips is a trapezium. Okay, and then you work out the area of each of these strips. Okay, and then you add them. So if this was 5, if this was 10, and if this is 7, so area would be 22. All right, so if you had a curved sort of shape, the graph was a curved sort of shape, you're going to sort of, this is probably going to be an overestimate because this part is not part of the area you want to work out. So this is actually the area you want to work out, but you've actually worked out the areas of these strips here, which is slightly bigger than the actual area enclosed in the red sort of ink. All right, so we'll see how that works. Okay, so I'll give you a function. So I'll give you this function to use the trapezium rule. So y is equal to x squared plus 1. Okay, okay, so here's what I want to do. This is the y is equal to x squared plus 1 graph, and I want to figure out the area between x is equal to 0 and x is equal to 5. Okay, so I have a more close-up view of this here. Alright, so here you have x is equal to 0 and x is equal to 5, and there are 5 strips that I want to find the areas of, and then add them all together, and I'll be able to figure out what the area is, what this area is. Okay, so what I need to work out the area of each of these trapezia, alright, is I'd need height 1. So this height here is 1. When you have x is equal to 0, that height is 1. Here, this height here is 2. Alright, and likewise I need to figure out each of these heights. Okay, so I figured out these points here. Alright, so this is just basically going to be 1, 2, 3, 4, because each of these strips is actually 1 unit in length. Okay, so the equation to figure out the area of a trapezium is this, which is base length times height 1 plus height 2, that added together and then divided by 2, and then you times all of that by the base length. So the base length is of course 1. So if I do it for the first one, it's going to be h1 is 1, h2 is going to be 2. Okay, and then that result I divided by 2, so that's 3. 3 divided by 2 is 1.5. 1.5 times 1 is still 1.5. Okay, so that small box there has an area of 1.5. Likewise, I do the same thing and figure out the areas of these strips here. Okay, so these are the areas of each of these strips, so I'll have to add them all together. Okay, if I add them all together, that's what I get, 47.5. Okay, right, so this is an approximation. As you can see, now the trapezium have counted an area which is not actually part of the graph and between the graph and the x-axis. So this area here and this area here. All right, so all those are extra bits, okay, that are not part of the not part of the area. Okay, so let's use definite integrals to integrate this between 0 and 5 and work out what the area is. Okay, alright, so I have the results here ready for you. So when I do the definite integrals between 5 and 0, the answer that I get is 46.7. Alright, now if I compare that with the answer that I got using the trapezium rule is 47.5. So as I've said before, the approximate answer is an overestimate because you're counting all these unnecessary bits of spaces here when you use the trapezium rule. Okay, so that's an overestimate. Okay, an overestimate. Okay, now in the exams they tend to ask why it's an overestimate. Alright, so the reason that you'd have to give here for this is that the graph bends inwards. Okay, that the graph bends inwards. Okay, so that's why you get an overestimate. So there are times also you get an underestimate. That's if the graph bends outwards. Okay, you get an underestimate for certain graphs if you use the trapezium rule to work out the area. Okay, a graph that would bend outward would be looking something like this. Okay, so if I got strips here between certain values, okay, now the trapezia miss out on these little gaps here. Okay, but the actual area contains these gaps. Okay, so here it would be an underestimate if I use the trapezium rule, because the graph bends outwards. Now what you see here is the general formula that you use to work out an area under the graph and the x-axis using the trapezium rule. Okay, now at first glance this looks a bit daunting, but it's actually quite straightforward how you use this formula to work out an area. Okay, now we'll go back to the example that we've just done here. Alright, the example that we've just done here. Now I've worked out the area under the graph. Okay, now I did a tedious process. I had to work out the x coordinates and the y coordinates and then the area of each of these strips, okay, which is a trapezium. Alright, now there's a simpler way of doing that. Alright, is if you follow this formula here. Okay, alright, now I'll show you how this formula is derived. Okay, now let me work out the area of the whole, well, of each of those trapezia. Okay, and this is what you do. B times h0 plus h1 over 2. Alright, now that's the area of one trapezia. Okay, so if I go back to this, okay, you'll see h0 is the first height, okay, which is this. h1 is the second height. Alright, and the base length is this length here, which is 1. Alright, and then the second trapezia would be b times h1 plus h2 divided by 2. So similarly you keep doing this until you work out the areas of each of the trapezia. Okay, there you go. So that's the area of each of those strips. Okay, we got 5 strips, and you have 1, 2, 3, 4, 5 strips. There are areas of 5 strips. Okay, but you could see here this b is being multiplied every time. Alright, so I'm going to take the b out as a common factor. Alright, and that's a common factor. I could also take out a half as a common factor. Yeah, so that leaves me with everything inside these small brackets. Okay, so that's h0 plus h1 plus h1 plus h2. Okay, so that's what you get. Alright, but you'd notice, except for the first and the last strip height, every other height is doubled. Alright, because you got h1 plus h2. So I'm going to do this now. I'm going to take the h0 and h1 separate, take that separate, and I'm going to have h0 and hn, the last one, and I'm going to have 2h1, I'm going to have 2h2, 2h3, 2 H4. Alright, 2HN is basically the 5. Alright, the last strip. H0 is the first strip. Alright, first strip height. Okay, now all of this is now multiplied with by B. Okay, and remember this half is actually multiplying this whole lot here. Alright, so I could take a 2 out as a common factor from this one, can't I? Yeah, so if I take a 2 out of a common factor, the half only affects these two only. Alright, because if the 2 comes out as a common factor, that 2 cancels out this half. Alright, so that's there, and then the rest, all I've got to do is just write them without the 2. Okay, alright, so that's the proof for the trapezium rule. Okay, now you'd never get asked to prove this, but it just helps you to know where the rule comes from. Okay, so if I go back to the example that I showed you here, alright, now here I didn't use that rule. Okay, so if I were to use that rule, okay, the question would be structured something like this. Alright, they'll say for this graph, y is equal to x squared plus 1. Work out the area under the graph between x is equal to 0, x is equal to 5, and the x-axis. Okay, by using 5 strips. Okay, you have to use 5 strips. Okay, so if I had to use 5 strips, then I have to divide my spacing between 0 to 5. I need to go up in ones, so that way I'll get 5 strips. Okay, so therefore my B is 1. Alright, my B is 1. Alright, my B is therefore 1. My B is therefore 1. And the number of strips I have is 5. Alright, and my function is y is equal to x squared plus 1. Alright, and my first height, which is h0, alright, h0, I have to start from 0. Okay, because I'll have 6 heights to get 5 strips. 1, 2, 3, 4, 5, 6. 6 heights to get 5 strips, so it's better to call the first height 0, so that the last height, which will be the same as using 5 strips, so the numbers don't change there. Alright, so my first height is 1, which is h0. Alright, and I'll fill out the rest of the heights. Okay, now all what I've got to do is substitute these values into this formula. Alright, my B is 1. Okay, and then I open up this brackets. My first height h0 is 1. My last height h5, hn I say, because that's n is equal to 5. My last height is 26. That divided by 2, and I'll have to divide that result by 2, plus I'll have to add all the other heights, which is 2 plus 5 plus 10 plus 17. Okay, if I simplify that, I get this, and if I simplify this, I get 1 times 47.5, which is in fact 47.5, and that's the answer that we got previously. Same answer, 47.5. Alright, but now we've used the trapezium rule to work it out. Alright, because it's simpler. Alright, we wouldn't have to individually work out each area of each trapezia. Just plug the values into this formula and you get the answer. Alright, I hope you found that helpful. I'll see you soon. Bye bye.